Hi, my name is Sofia Criscitiello, and this is my YouTube project for ENTO 320 Honeybee Biology. This presentation is titled Honey, I Remember That Flower, the Influence of Age and Circadian Timing on Associative Memory Persistence in Apis mellifera. So some background. Honeybees rely heavily on associative learning to forage efficiently. This means that they must learn which flower cues predict nectar and pollen rewards. These cues include the color, shape, and fragrance of different flowers. One of the most common experimental paradigms for studying honeybee learning is olfactory appetitive classical conditioning. The proboscis extension reflex, or PER, is a feeding behavior in insects like bees and flies where they extend their proboscis to consume a sugary liquid. In the case of honeybees, they extend their proboscis when presented with sucrose, and through training, a neutral odor becomes able to elicit PER. PER conditioning is used to study acquisition, memory, retention, and extinction, among other topics. Here's some additional background. Honeybee learning capacity can be affected by several things, one of which is social roles. Studies show that older foragers show significant learning deficits compared to age-matched nurses, but older bees that revert from foraging to nursing tasks can regain their learning abilities. We will be looking deeper into how age and circadian timings can influence the strength and persistence of associative memory in Apis mellifera. This first study looks at circadian effects on learning. The study showed that honeybees demonstrate better learning capabilities in the morning compared to the afternoon. Bees kept in constant darkness show better learning in the morning, indicating an endogenous rhythm. An endogenous rhythm is a naturally occurring biological cycle, like the human sleep cycle, that is internally generated by the body's biological clock. As you can see by the graphs, the taller bars represent the early or morning feeders, while the lower bars represent later feeders. This next study looks at age effects on learning. Brief olfactory stimulations at the early stages of adult bees' lifespan can improve the memorizing of new learning events. Earliest associative learning, either at the first 4 days of adulthood or at the 5 to 8 day mark of age, clearly modified the level of retention of long-term memories acquired thereafter. The graphs on the right show the decreasing memory retention of honeybees to different smells or odors. The left three graphs, the tested odor is LIO, and the tested odor on the right graphs is PHE. And as you can see, as the honeybees get older in age, their PER decreases. And then this last study explores the combination of age and circadian timing on memory. Based on the data, honeybees do not begin experiencing biological patterns until the 5th to 7th day after emergence. As you can see here, shows the 5th day, and then in the bottom graph shows the 7th day. So in conclusion, based on the data, honeybees do not begin experiencing biological patterns or circadian rhythms until the 5th to 7th day after emergence. When comparing all of the data, younger honeybees between 5 to 8 days old will show better memory retention. This age is most optimal for honeybee learning. The significance of these studies include By elucidating how honeybees learn and remember floral cues, we can better predict foraging patterns, improve pollination strategies, and support crop productivity. Honeybees serve as an accessible model for studying fundamental principles of learning, memory, and neural plasticity, bridging molecular and behavioral neuroscience. Insights into factors affecting memory, such as age, circadian rhythms, social roles, and environmental stressors, can inform conservation strategies, helping to mitigate the effects of pesticides, habitat loss, or climate change on pollinator populations. Here are my 6 peer-reviewed references, and thank you for your time.